our my project is like it's an AI plus healthcare model. So in that we kind of like the user has to upload an image of them doing yoga, like any yoga pose, and our model will detect what that pose is first, and then it will give like a score, like a percentage of how well they did it, and then it provides some kind of feedback, so how they can improve after that.
Oh,
And
nice.
we, yeah,
Creative
so
project.
thank you.
Okay, so we will start with the presentation. You have to start with your introduction and you have to present whole your PPT. Okay, once again. Okay, you can start now.
Good evening. My name is Anushka, and today I'll be presenting our AI plus healthcare model, which is named as PosturePal, and it's an AI yoga powered yoga posture detection and correction model. My teammates in this project are Sam and Randeep. So we chose this name for our project because it clearly like reflects both our function and maybe kind of like our personality of the app, because posture like directly represents our app focuses on improving body alignment during yoga and exercise, and pal kind of conveys that the idea that our application is kind of friendly and it does not judge, it kind of like just helps you through the process. So moving on, so this is kind of how and why we chose our this as our project. um Even like small alignment mistakes in yoga can lead to a strain or an injury, especially for beginners. Like I like some sports, so I was first going to think about maybe like a risk of injury detection and something like that, but we kind of needed to agree on something within our teammates and their their field which they wanted to do. So we focused on yoga because that's really important for us nowadays, and most people practice yoga alone using online videos without any real time feedback, and this kind of creates a gap between watching yoga and like doing it correctly. So that's what we thought. So these are some existing solutions that fall short. Like there are a few ways that people try to solve this problem, but it didn't really help that much. So mirrors, like how people do while doing yoga, they kind of look in the mirror and they judge themselves. Like they don't have like a second opinion, so it doesn't really work that way. For example, maybe like videos don't really respond to their mistakes, and personal trainers can be expensive. So there's a clear need for an affordable and intelligent solution, which is kind of interactive too. Then this is where PosturePal comes in. Like it's like a virtual yoga coach. A user just uploads an image of them performing a pose. Then the system identifies the pose, evaluates its posture correctness, and then it provides a clear feedback. It's like guidance without any judgment. Coming to the system architecture overview, I'll kind of briefly explain how the system works. The input image is processed step by step, and first it detects the body landmarks. It then extracts the features from those landmarks, and next a machine learning model will predict the yoga pose, and finally the posture rules evaluate correctness and generates feedback. So coming to the training data set, the model was trained on a structured like yoga data set that we found on Kaggle. I'm pretty sure a lot of people will know what this is. And each yoga pose is stored in a separate folder named after its Sanskrit name. This data set contains around 2,500 to 2,700 images, I believe, and it covers more than 40 yoga asanas. This structure like helps people keep themselves organized, so that's why we thought it was helpful. Then to understand the human posture, um, we used MediaPipe Pose. Um, it detects like around, I think, 33 like main body landmarks, including shoulders, hips, knees, and ankles, I think. And then each of the landmark um, includes like a position and visibility information, because the computer needs to understand how far away one person is, or maybe understand it through the different angles there are. um, and then it allows the system to understand the body from one single image. mm, then coming to landmark normalization, to unlike raw landmark data can be really misleading, because camera angles can and the distances will change a lot when we look at it. So we normalize the landmarks by centering the pose at the hips, I think, around at the hips, and it scaled it accordingly. And this makes sure that our model would focus on the posture and not where we just place the camera. Next, we converted the landmarks into like some numerical features so the computer can understand this. They those included the joint angles at elbows and some other key distances between the body parts. And angles are really important here because they remain consistent across like different body sizes. Like even like we need to compare different types of people, like no matter how their sizes are. So we like every single project will face some kind of issues. So we came up with a lot of challenges at that time. So like currently I was facing a lot of issues because I was working on a Mac, and my mentors and my peers, they were all working on Windows. And up until now I had a big issue. The Python installment was different on my computer so it was a really big challenge for me on that. And I mean, we overcame it. We in like I got they got Anaconda prompt, but I had to use terminal for it because I was on Mac. So some of the challenges like together we faced was like maybe some yoga poses, like they look really similar, so um the computer won't be able to detect it. So we kind of normalized the landmarks and changed the module the model on like different poses that we had, like each individual ones. So yeah, this is how we improved our system. And this is our Streamlit web app. Um, so users simply just upload an image and they'll get their output on that. So it makes our AI accessible to other people. Like it makes it better. Thank you.
Okay, so firstly, I just want to say your presentation is fabulous. I just like the way you presented. I just like the visuals in the presentation. By just looking at the visuals and everything, looks like you have created the presentation.
Thank you.
Okay, so your presentation was good. So like, do you have your project ready? Like, can you just
Yes,
demonstrate it?
I do. I'll just present it.
Okay, so
Okay, can you see it?
yeah, it's visible.
Yeah, let me just get the images that I have so I can
Okay.
upload it. Okay. The good thing about this model is it doesn't always require a human to do it. Like you can just upload images like this, like a clip art, and it gives you feedback on that. So this image shows like a perfect one because it was kind of animated to look that
Okay.
way. But if we go to some other image, um let me just get it. uh yeah, so you can see I uploaded a different image, and it gives a score, and it gives live
Oh,
feedback of what the person was trying to do. So it detected the pose and it gave a percentage score for it, and then it gave um feedback on it on how one should improve if they did that. So
okay.
yeah.
So the thing I like the most was it also guesses, it also predicts the asan that we are like the
Yeah.
person. Okay, great. Also, your project looks like it's work completely good and it's just have much functionality, and that's probably someone is if someone is going to use it, it like it provides a benefit to them. Okay.
Thank you. We still
Okay,
have
great.
some problems that our mentor was going to help us. Like they were looking for alternatives for it. But we will. It's working fine right now, but we have to look into it a little bit. Yeah.
Okay, like you can contact the mentor anytime, he will help you for sure.
Yeah.
Okay, great. Like you can just turn off the presentation. Let's just have one-on-one communication.